Okay, in question number 21, we have been given 2 plus sine 2x upon 1 plus cos 2x into e to the power of x dx. Okay, so a little bit of note here or idea for you is this, that whenever e to the power of x is with a bulky function, especially trigonometric, then we convert this function into this form, e to the power of x into fx plus f dash x. Okay, meaning to say we try to convert this function into in this form if possible. So by experience we know that sometimes it is possible and sometimes it is not possible. So it is up to experience, but this thing is always kept in mind whenever e to the power of x is going to multiply a bulky trigonometrical function, because we know that whenever e to the power of x into fx plus f dash x is given to us, this is function, this is derivative, then it is equal to e to the power of x into fx plus c. Okay, so to begin with, first of all, what I am going to do, I am going to take this term and I am going to write sine 2x as equal to 2 sine x into cos x, and 1 plus cos 2x, this will be written as 2 cos square x. Okay, by applying the formula that cos 2x is equal to 1 minus 2 sine square x, 2 sine square x, or 2 cos square x minus 1. Okay, so substituting cos 2x is equal to 2 cos square x minus 1, this 1 and 1 is going to cancel out and we are going to get this term. Okay, so this 2 cancels out throughout and I am going to get this as 1 plus sine x into cos x upon cos square x dx. Now I am going to divide the numerator separately by cos square x, so I am going to get 1 upon cos square x plus sin x cos x into cos square x dx. Okay, so 1 upon cos square x will become sec square x. This cos x, this power is going to cancel out, so I am going to get tan x. Okay, and this e to the power of x is going to remain as it is. Okay, this is going to keep on multiplying here. Okay, sometimes this happens, we begin with a problem, unnecessary terms are not written, so when we remind of, we write it. Now this is function and d upon dx of tan x is sec square x, so this is f dash x, so this will be equal to e to the power of x into tan x plus c. So this is our required answer. Okay, now in question number 22, we have been given this function x square plus x plus 1 upon x plus 1 whole square into x plus 2. Okay, so this is a typical problem which we have to solve it by partial fraction. So to solve it, first of all, I start the process of resolving it into partial fraction. X square plus x plus 1 into x plus 1 whole square into x plus 2. This will be equal to a upon x plus 1 plus b upon x plus 1 whole square plus c upon x plus 2. Okay, on cross multiplication of this term present in the denominator, I am going to straight away get x square plus x plus 1 is equal to a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 whole square. Okay, now we mark this as equation number 1. Okay, we can calculate here the value of c and b easily. Okay, for that I'm going to place x plus 1 is equal to 0. This gives me x is equal to minus 1. On placing x is equal to minus 1 in this equation, I'm going to get this as 1. This will be equal to 0. This will be equal to b into 1, that is will be equal to b. This will be equal to minus 1 plus 1, that it will be equal to 0. So straight away I get b is equal to 1. Okay. Now to calculate the value of c, I'm going to place x plus 2 is equal to 0 or x is equal to minus 2. Okay. So placing x is equal to minus 2 in this equation, this will become 0, because minus 2 plus 2 is 0. This whole term is going to become 0. Again x is equal to minus 2 here, this is going to become 0. On placing x is equal to minus 2, so this is going to become 4 minus 2 plus 1, so this will be equal to 3, and this will be equal to minus 2 plus 1, so this will be equal to 1. So I'm going to get c as equal to 3. So we get two values. Now to calculate the value of a, it is also very simple. I'm going to place x is equal to 0 in this equation. This equation I'm going to place x is equal to 0. So here I'm going to get 1, 0 plus 0 plus 1. I'm going to get this as 1. This will be equal to 2a. This will be equal to 2b and c. Okay, now since we are knowing the value of b and c, so we can now calculate the value of a. So this will be equal to 2a plus 2 plus 3. So we are going to get this is going to come here, become minus 4 upon 2, that will be equal to minus 2. So we are going to get a is equal to minus 2. Okay. So therefore we have x square plus x plus 1 upon x plus 1 whole square into x plus 2 dx as equal to, placing the values of a, b and c in this term, I'm going to have minus 2 upon x plus 1 plus 1 upon x plus 1 whole square plus 3 upon x plus 2, and this would be integrated now. Okay. So to print the final answer, this would be equal to minus 2 log of x plus 1. This will be equal to minus 1 upon x plus 1 plus 3 times log of x plus 2 plus c. Okay, so this is our required answer. Okay.